This lesson is for FST Lesson 7.7 on factoring sums and differences of powers. First example is a good review of 7.6. When you find a cube root of a number other than 4, you can expect that there's going to be two more answers, because a cube root means to the power of 3. And so if we took that and tried to solve, we would add negative 64 to both sides, and so we'd be solving for x cubed minus 64 equaling 0. If one of the roots, or zeros, is going to be a 4, then we know that the factor that came from was x minus 4. If we divide our polynomial by the factor that we know, we'd have x cubed, keeping in mind that there should be a squared and a plain x term that we're missing. So we're going to fill those in with zeros. We're going to go ahead and do long division here. You can pause the video, try long division on your own, and then the answer will pop up for you. And I apologize, there was a 0x squared and a 0x here that got omitted. So when you are finished with your long division, you're going to get x squared plus 4x plus 16. So our other two zeros are embedded inside here. We should try to factor that in order to find those other two factors, or the other two roots. So we're looking for factors of 16 that add up to 4, and unfortunately there are none. So then we're left with doing our last resort, which is the quadratic formula. The hint here, or the idea here, is if we can't factor it, then those other two factors are probably going to be imaginary, and the only way we'd be able to get those is if we did the quadratic formula. So a quick reminder here, opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So again, pause the video, get your quadratic formula figured out, and then we'll move on from there. So here we go. When we fill in 1, 4, and 16 for a, b, and c, we end up getting negative 2 plus or minus 2i square root of 3. We ended up with a negative 48 under the radical. If you simplify that into a negative 1, a 16, and a 3, because 16 is the highest perfect square that goes into 48, we end up with 4i there with the square root of 3. The 4i square root of 3 can reduce with the 2 on the bottom, just the 4 and the 2 reduce, and then this 4 and this 2 reduce as well. So we do get our other two answers here, negative 2 plus 2i square root of 3. That's one of the other cube roots. The third one is negative 2 minus 2i square root of 3. If you were to take negative 2 plus 2i square root of 3 and multiply it by itself 3 times, eventually it would turn back into a 64. Same thing with the other 0 that we got. Difference of squares is going to be a focus today. That's going to be something that we're going to do a lot of. And then that's going to lead into sums and differences of cubes, and then sums and differences of numbers higher than 3 that we can factor. So just a quick review on difference of squares, because that's usually a first avenue that you want to take, a first course that you want to do, first thing you should try when you're asked to factor. The very first thing you're supposed to do when you factor is find a GCF, and this one does have that. So we're going to factor that out. When we're all done, we end up with x squared y squared minus 9. I took away a 9 from each factor, or each term. Now I can factor what's inside the parentheses using the difference of squares. So the 9 is just going to hang out and sit there. And then I need the square root of the first term and the square root of the last term. So the square root of the first term is just going to be xy, so I put that at the beginning. The square root of 9 is 3 and 3. And the difference of squares, remember, you put 1 plus and 1 minus in between. So using that idea, let's move on now to difference of cubes and sums of cubes. So the sums and difference of cubes theorem, it's basically a little template or a little chart that you're going to use to factor when you have a binomial that's being cubed at the beginning and the end with either a plus or a minus. What you're going to do is cube root the beginning and the end and put that as a binomial. If it's a plus, then your first binomial is plus. If it's a minus, your first binomial is going to be minus. Then you're going to use those two cube roots to build the rest of your factor. So the first term here is going to get squared at the beginning. The last term here is going to get squared at the end. And then in the middle, you're just going to take the two pieces and multiply them together. Keep in mind that when you do a sum, the signs are going to alternate. So notice here we're going to have three signs, and it's going to start with plus and then it's going to do minus plus after that. The template or the procedure that you're going to use is going to stay the same when it's a minus. The only difference is you start with a minus and then it's plus plus after that. So let's put this into practice now with some examples. Let's start with the one on the right. So we're going to do the cube root of x cubed and the cube root of 10. So the cube root of x cubed is just going to be x, and the cube root of 10 is just going to be cube root of 10. If it was a number like 27, then we would have said the cube root was 3, but we don't know the cube root of 10, so we're just going to leave it with the radical symbol. We have a plus sign here, so we're going to include a plus sign here. So what I've built right now is just the x plus the y in my template. Now I'm going to use those pieces to build the rest of my answer, keeping in mind that the rest of my answer is going to have a minus here and a plus here. At the beginning here, I'm going to take the beginning term in my binomial and I'm going to square it. So nothing interesting there, it's just going to be x squared. In the middle, I take the two pieces that I'm working with, the x and the y, and I multiply them together. So it's just going to be x cube root of 10. So those just sit right next to each other. If they happened to be numbers, I would multiply those. And then at the end, I need to do the y value and square that. So in this case, I want to take cube root of 10 times itself. So let's just show what that looks like for a moment, just so you can see it. So it's cube root of 10 times itself. When the roots or the radicals are the same, you can combine them into the same radicals. We end up with 10 times 10 there, so that's going to end up being cube root of 100. And so then that's it. That's all we can do on this one. Cube root of 100 is our final answer at the end. So that one's not very interesting, so let's try one now with numbers and letters. This is book example 2. So this is also a cube problem. This time we're going to do the subtraction. So I need to find the cube root of the beginning and the cube root of the end. So something times itself that equals 27, something times itself 3 times that equals a cubed. So I'm going to start with that, and I know that I'm going to have a minus sign in between. So what number times itself 3 times is 27? You have to do either you know that or you'll have to do trial and error. So it's going to be a 3. What times itself 3 times is a cubed? That has to be a. You do the same thing for the second portion, the 8b to the 6th. Number times itself 3 times that's 8 is 2. I don't need to worry about whether or not it's negative because I've already put in the minus sign in my factor. And then a number times itself 3 times that equals b to the 6th. This one might be easier to visualize. So if we do b times b times b, that's got to turn into b to the 6th. So if I do a power of 2, those powers get added to turn into the 6th. So b squared is what I'm looking for there. So 2b squared is my second term, or my y term in this case. So now I'm going to build the rest of my answer. The rest of my answer is going to be all plus signs. So at the beginning, I'm going to take my x and I'm going to square it for the beginning of my second part of my answer. So I have to take 3a times 3a. So for your notes here, I'm just going to show that it's 3a squared. So that's going to be 9a squared. In the middle, I take the two pieces that I'm working with and simply multiply them together. So that's going to be 3a times 2b squared. And don't worry about the sign because I already know it's going to be positive. 3 times 2 is 6, and a times b squared is just going to be ab squared. And then at the end, I take my 2b squared and I have to square that. So I take 2b squared and square it. 2 gets squared to make a 4. B squared squared is going to be b to the 4th. And so then that's my answer. Keep in mind, students, that at this point you would want to look at your two sets of parentheses and see if you can factor any further. The focus for today, however, is just getting comfortable with using the sums and differences of cubes theorem. Later on in the chapter, you'll have more opportunities to factor further. Well, let's try one where you have to factor more than once, and that's book example number 5. So this time they want you to factor x to the 6th minus 64. Another thing that is going to be helpful to you is if you're working with multiple types of factoring, do the difference of squares first, if you can, before you try anything else. So using the difference of squares is not only an easy factoring to use, but it's also typically the first thing you want to try. So I want to find something times itself that equals x to the sixth. So that's going to be x cubed and x cubed. I'm going to do a plus and a minus, and then a number times itself that equals 64, so that's going to be 8 and 8. Now from here, if you can factor further, you should. So here we've got cubes, so we're going to do both of those. So I'm going to take the first one and do that one in light blue so you can kind of visually distinguish one answer from the other. So I've got cubes now. I'm going to do x, cube root of x cubed is x, and the cube root of 8 is 2. I have a plus in the middle, so I'm going to keep my plus there. Now I'm going to use the x and the 2 to build the rest of my answer. Let's peek back at the template for a moment. It's going to be x squared minus xy plus y squared. So I'm going to say x squared at the beginning, 2 times x in the middle, and that needs to be a minus. And then I'm going to take 2 and square that at the end, so that's going to be a 4. So that's the first one. Now I'm going to do the second one, and I'm going to do that one in green. It's going to be the same answer, so I'm just going to rewrite it, but this time it's going to have a minus at the beginning. So that's going to be x minus 2, and then the rest of the answer is going to be the same, just with a plus here. So x squared plus 2x plus 4. Students should pay attention to whether or not you can continue to factor further here. I don't believe you're able to, because factors of 4 are never going to add up to 2. But keep in mind that that might be a possibility that you could factor these trinomials further. But I think at this point we're done with that one. So that would be your final answer here. I do want to look at one thing with students, and that is a practical example for where factoring will help you factor just a plain number. So this is talked about in book example 3, page 482. So they want to factor the number 1027, and so they recognize the fact that 1027 is the same as 1000 plus 27, and both of those numbers are cubed numbers. 10 cubed is 1000 and 3 cubed is 27. So we can use the cube sum template that we just used to try to figure out the answer. We can probably do it without a calculator. So you're going to take your 10 and your 3, and those are going to be your pieces that you're going to use to build the rest of the answer. So if you have 10 and 3, those are the cube roots of each piece. Then I'm going to do 10 squared here, which is going to be 100. Take the two pieces, multiply them together, that's the middle term, that's going to be 30. And then the last number is going to be squared. So now I just follow the signs and I do the order of operations. So I'm going to get 10 plus 3 there is 13. Over here I'm going to do 100 minus 30, that's 70, minus 9 is going to be 61. So all you have to do there to factor 1027 is know that it's going to be 13 times 61. So it's kind of a cool way to factor using the sums of cubes theorem that we just looked at. And if you check my math there, I did 100 minus 30 to get 70, and then I subtracted the 9 to get the 61. I should have added there to get 79. Sorry about the error. Our last topic for today is how to do sums and differences of odd powers. Keep in mind that this yellow box that the book provides is unhelpful. I will refer to it as we go through the examples, but I think the examples will be more meaningful to you than the yellow box itself. Keep in mind that the pattern that we're going to see here is going to be very similar to the cubes that we just finished. We're going to do this one first. We'll start with an easier one, and then we're going to do the longer one. All you're going to do here for the sums and differences with odd powers is take, just like we did with the cubes, the roots of each of the pieces. So for this one we're going to do, I'm going to kind of slide it way over here, so I'm going to do fifth root of x and fifth root of y, so it's just going to be x and y. Again, the signs are going to be repeating, so I know I'm going to have a minus here. And then the rest of the signs on this one are going to remain as a plus, just like we did with the minus or the difference that we did with the cubes. Now when you build the rest of your answer, you're just going to decrease your power by 1, which is what this is indicating here. So the power is a 5, so when I write out my answer here, that's going to be to the 4. Then leave some space. My x's are just going to decrease until I run out of x's. Leave some space here, don't put in your parenthesis yet. Now we're going to go back and fill in the y's. The y's are going to build from the right, and those are going to decrease going right to left. Leave some space after your x. The y doesn't go with him, it goes after. So the y is going to be y to the 4. Then the y's are going to decrease next to the x's. So it's going to be cubed, squared, and then a plain y. Remember that this was a minus. The minus is going to appear in the first term, or the first chunk of parentheses, and then everything else after that is going to be a plus. So we're just going to put pluses in. You can always verify that you did it right by making sure that all the powers add up to 4. So I've got a 4 here. This is y to the 1, so that would be a 4 there. 2 and 2 is 4. X to the 1 there, that would make a 4, and then this would make a 4. You can also verify you should have an x that's all by itself at the beginning, and you should have a y that's all by itself at the end. And then all the middle terms have x's and y's combined. So there it is, you just factored a fifth root polynomial. Let's do the last one, which is book example 4. We're going to do that kind of down below here. So it's the same type of setup, but now we're just going to have powers of 7. And we're going to use a's and b's instead of x's and y's. So again, I take the 7th root of each piece, so it's going to be just a and b. When you're doing a sum, the signs are going to be the same at the beginning, but then the signs are going to alternate after that. So when it's a sum, make sure you have your signs alternating, just like we did with the cubes. So when I build the rest of my answer, I'm going to start with a. I'm going to decrease my power by 1, so that's going to be a to the 6. So I'll leave some space, a to the 5, a to the 4, and so on. Then when I build the b values, those start after the a with a power of 6, and then those are going to decrease as I move to the left. And then when I go back through, I want to make sure to put the signs in, and they need to alternate. I have a plus because it was a plus to begin with. Now I do minus, plus, minus, plus, minus, plus. Making sure you have an a all by itself at the beginning, a b all by itself at the end, a's and b's in the middle that all add up to a 6 for the power. 5 and 1 make 6, 4, 2, 3, 3, 4, 2, and 1 and 5. So there we go. There's our answer now for a to the 7th plus b to the 7th. Final comment here is that a lot of these questions will have numbers in front of the letters, and so students will need to practice those in the homework.